a heating element converts electricity into heat through the process of resistive or Joule heating. Electric current passing through the element encounters resistance, resulting in heating of the element. Unlike the Peltier effect, this process is independent of the direction of current flow. Metal heating elements, Nichrome. Most heating elements use Nichrome 80/20 wire, ribbon, or strip. Nichrome 80/20 is an ideal material, because it has relatively high resistance and forms an adherent layer of chromium oxide when it is heated for the first time. Material beneath this layer will not oxidize, preventing the wire from breaking or burning out. Resistance wire. Metallic resistance heating elements may be wire or ribbon, straight or coiled. They are used in common heating devices like toasters and hair dryers, furnaces for industrial heating, floor heating, roof heating, pathway heating to melt snow, dryers, etc. The most common classes of materials used include Canthal wires, Nichrome 80/20 wire and strip, cupronickel alloys for low-temperature heating. Etched foil elements are generally made from the same alloys as resistance wire elements, but are produced with a subtractive photoetching process that starts with a continuous sheet of metal foil and ends with a complex resistance pattern. These elements are commonly found in precision heating applications like medical diagnostics and aerospace. Radiative heating elements. A high-powered incandescent lamp usually run at less than maximum power to radiate mostly infrared instead of visible light. These are usually found in radiant space heaters and food warmers, taking either a long, tubular form or in a 40 reflector lamp form. The reflector lamp style is often tinted red to minimize the visible light produced. The tubular form comes in different formats: gold-coated, made famous by the patented Philips Helen lamp. A gold dichromatic film is deposited on the inside that reduces the visible light and allow most of the short and medium wave infrared through. Mainly for heating people. A number of manufacturers now manufacture these lamps and they improve constantly. Ruby red coated, same function as the gold coated lamps, but at a fraction of the cost. The visible glare is much higher than the gold variant. Clear, no coating and mainly used in production processes. Ceramic heating elements, molybdenum disilicide. Molybdenum disilicide, an intermetallic compound, a silicide of molybdenum, is a refractory ceramic primarily used in heating elements. It has moderate density, melting point 20-30 degrees Celsius, and is electrically conductive. At high temperatures it forms a passivation layer of silicon dioxide, protecting it from further oxidation. The application area includes glass industry, ceramic sintering, heat treatment furnaces and semiconductor diffusion furnaces. PTC ceramic elements. PTC ceramic material is named for its positive thermal coefficient of resistance. Most ceramics have a negative coefficient, whereas most metals have positive values. While metals do become slightly more resistant at higher temperatures, this class of ceramics has a highly nonlinear thermal response, so that it becomes extremely resistive above a composition-dependent threshold temperature. This behavior causes the material to act as its own thermostat, since current passes when it is cool, and does not when it is hot. Thin films of this material are used in automotive rear window defrost heaters, and honeycomb-shaped elements are used in more expensive hair dryers and space heaters. Polymer PTC heating elements. Resistive heaters can be made of conducting PTC rubber materials where the resistivity increases exponentially with increasing temperature. Such a heater will produce high power when it is cold, and rapidly heat up itself to a constant temperature. Due to the exponentially increasing resistivity, the heater can never be warmer than this temperature. Above this temperature, the rubber acts as an electrical insulator. The temperature can be chosen during the production of the rubber. Typical temperatures are between 0 and 80 degrees Celsius. It is a point-wise self-regulating heater and self-limiting heater. Self-regulating means that every point of the heater independently keeps a constant temperature without the need of regulating electronics. Self-limiting means that the heater can never exceed a certain temperature in any point and requires no overheat protection. Composite heating elements. Tubular heating elements. Tubular elements normally comprise a fine coil of resistance heating alloy wire, usually nichrome, that is connected at each end to a terminal pin and is electrically insulated from a metallic tube, of stainless steel alloys, such as zinc alloy, or copper, by a ceramic insulating material, fused magnesium oxide powder. The tube ends are frequently equipped with beads of insulating material such as ceramic or silicone rubber, or a combination of both to prevent the penetration of moisture into the element. These can be a straight rod or bent to a shape to span an area to be heated. There are two types of tubular heating elements widely used, namely, screen-printed elements, screen-printed metallo-ceramic tracks deposited on ceramic insulated metal plates have found widespread application as elements in kettles and other domestic appliances since the mid-1990s. Combination heating element systems, thick film technology. Heating elements for high-temperature furnaces are often made of exotic materials, including platinum, molybdenum disilicide, molybdenum and silicon carbide. Silicon carbide igniters are common in gas ovens. Electric stove. Many electric stoves have three types of heating elements: surface burners, bake elements and broil elements. Surface burner elements are typically either a coil type, solid type or a ribbon coil, as used in smooth top ranges. All of these normally consist of heating wire that uses an electric current to produce heat. The broil element is the heating element that is found at the top of the oven and produces a very high heat for broiling. This element is not used for the majority of baking and only provides about 10% of the heat. The bake element is found at the bottom of the oven. Most ovens use both the bake element and the broil element in a bake cycle, but with the bake element performing 90% of the heating. See also, thermoelectric effect, positive temperature coefficient, heated hose, heating mantle, molybdenum disilicide. References